Hello everyone, Brandon here. So about 5 days ago, we had this magnificent bloom from Amorphophallus titanum that we call lupin. And as I mentioned, everything above ground with these plants is temporary, right? So all of this will wither away. We can see that the spadix has collapsed in and fell in. That was probably fell in 3 days after it flowered. The spathe is starting to shrivel up and starting to kind of just dry down a little bit. It'll all become like this brown dried petal before the leaf stage even it occurs, which will follow maybe in a month or two from now. Even the stem will wither away. The only chance that this stem would stay around for a little bit is if it was pollinated, in which we'll see some berries forming inside there. So all of this, including the stem, will return back to the bulb, in which the leaf will continue up as I pointed out, some of these titanum leaves here. It'll become its like tree form again, or the big leaf form that we know these plants to produce. So all of this is starting to shrivel up, and so I'm going to demonstrate. I'm going to show. We're just going to open up this a little bit just to show you the male and female parts of this flower. I think it's really fascinating to see that. And again, all this is going to wither away. So we could, in theory, cut this off at the bottom, and we wouldn't hurt the plant at this point. This is all just going to dry up, and it's just so big. It takes so long for it to dry down. So I think we'll show you where all the pollination magic happens down in this flower. So you can see this is already squishy. So we're just gonna cut into here. We're just gonna cut a window, and again, this does not hurt the plant at this point. We are it's at the point of the development where it's just going to dry down at the time. And these plants are very spongy, as typical of aroids, the aroid family. So we're just gonna, and they're pretty thick, but inside you can see this is the female parts of the flower right here, and up above it is the male parts. There's the pollen right there. So that's the male parts right above that, and that's the female parts right there. Isn't that and just incredible looking? So that's how. So this plant requires that the pollen from pollinators such as flies and carrion beetles is transported to these female structures. This small orange circle would become the fruit if pollinated. Now these plants prevent self-pollination because of they're receptive during the smelly portion of when the flower blooms. And unfortunately, these plants drop their pollen the day after that they're receptive for pollination. So they prevent self-pollination because of this mechanism, this timing mechanism that exists. So that's how they go about protecting, their genetic diversity. This plant requires another flower nearby to be flowering about a day or two apart from when this one flowers. So you can imagine how rare of an event, but there must be some sort of synchronization that happens in the wild to help this process, because you think 10-15 years to produce a flower, and you have this one chance to fruit. Seems like a really rare event. So you might be wondering, what's up here. Again, this outer shell basically is the spathe. That was that giant thing that was open. The spadix again here is flopped down over. But if we look in here, up above the male parts of the flower, this is the bottom of the spadix that we're looking at right here. And so that goes all the way up, and that connects to the part that's flopped over at this point.